DeepSeek explained simply. This video assumes you're already familiar with the news around DeepSeek and the broader US and China context. Instead, I'll jump straight to the technicals behind the DeepSeek R1 Zero and the DeepSeek R1 models. Note that DeepSeek have also built other models in the past. DeepSeek is getting a lot of attention because of how efficient it was in its training and also in how it runs and reasons. So this video will only focus on the training aspect. I'll do a separate video on this part which will cover these concepts. This is all going to be based on DeepSeek's official technical paper, which covers a lot. So as a warm-up, let's start with a very simple analogy. Imagine you're raising two kids, one older and one younger, and you want them to learn how to do some house chores. For the older child, you spend a lot of upfront time and energy to teach them and supervise them on how to do house chores. You go through examples of, washing dishes and vacuum cleaning, and initially, they just watch and learn from you directly. After that, you give them some time to practice by themselves so that they master the house chores on their own. Awesome, your older kid can now do house chores. But that took a lot of time and energy out of you, and now your back hurts, you've got headaches. So when it comes to teaching your younger kid to do house chores, what's a more efficient way of training them? You don't spend as much time and energy trying to train them. Instead, you just tell them to watch and learn from your older sibling and practice chores by yourself, and eventually they'll learn how to do house chores on their own. And you probably saw this coming. The older kid represents how current models were trained, and the younger kid represents how DeepSeek was trained. Broadly speaking, current models have been trained by supervised fine-tuning, or SFT, which is basically your watch and learn process, and reinforcement learning, or RL, which is basically your go practice by yourself bit. SFT requires lots of labeled data. I mean, tons of labeled data, because an AI needs to see heaps of examples in order for it to predict or create new ones. And getting labeled data is not easy. You have to collect it, and then you have to clean and organize into structured formats. You then often have to manually label them. And this costs a lot of money, time, and often runs into copyright issues depending on how you collected the data. Now, in theory, you can train a model purely based on SFT, but that requires a lot of data. So often SFT is combined with reinforcement learning to help refine the model even further. Reinforcement learning is when you give an AI a policy that sets out rules of what it can and cannot do, and also the goals that it should achieve. The AI then takes random guesses or actions that try to achieve the policy goals. If it gets close to them, it's rewarded. If it gets away from the goals, it's penalized. And this system basically incentivizes the AI to maximize actions that get the most reward and minimize actions that get penalized. Reinforcement learning is basically guess and check, or trial and error. And the advantage is that you don't necessarily need to give an AI heaps of data. You just need to let it to repeat a process a lot of times so that it can guess and work out the right actions to take. Now, current model training techniques tends to assume that you need to spend an equal amount of focus on SFT and RL. But what makes DeepSeek fascinating is that it's shown that you don't need to spend that much time on SFT, rather you just need to max out the RL. DeepSeek has shown a new way of doing RL that is apparently very efficient. This new method has two secret ingredients. First is the Group Relative Policy Optimization, or GRPO, or GRPO. The second is something called multi-stage training. This separation also explains the difference between DeepSeek R1 Zero and DeepSeek R1, which I'll get to later. To understand GRPO, let's go back again to the basics of reinforcement learning. Traditional reinforcement learning methods often have something called a critic model, which is a separate model that sort of guides the AI on what sort of random actions it takes in order to optimize its rewards. Think of it as like a classroom where students have to learn a topic, but you have a tutor in the classroom to sort of guide them in their self-learning. That tutor is the critic model. But critic models are like their own separate model. They take up space and memory. GRPO is basically when you remove this critic model and instead you rely on a simpler metric, which is like a group average score, to guide the AI's actions. This is the actual formula for GRPO, which looks complicated. So let me give you a simple example. Let's say you ask the model, what is 2 plus 2? Under the GRPO training process, the model will produce multiple responses to that very one question. And these responses are grouped into groups, hence the word group. In each group, each response will be scored based on accuracy and format. Accuracy refers to how correct the answer is, and format looks like the actual styling or expression of the answer. For example, if it's bullet list or full sentence or just a number, or in the case of coding responses where it's got the right coding syntax. These metrics then set out the rewards for each response. So for example, in this group 1, the answer 4 gets 1 point, same as this one. This one gets, let's say, 0.8 because of its sentence structure, and this one, 6, which is completely wrong, gets penalized, for example, -1. And you repeat this process for all the other groups. Then you apply some maths to work out which of these groups has the best group score relative to the other groups, hence the word relative. And whichever group has the best score, which I think is group 1 here, that basically updates the policy, hence policy optimization. And so the theory is that through this process, the policy naturally becomes more clear, which gives the AI a better idea of what actions to take to maximize its reward. And apparently this method is much more streamlined and more efficient than using a critic model. And so to use the classroom analogy, instead of having a tutor, the students instead learn from the best performing student, kind of like a role model. By the way, this is a very simplistic example. There's also a process called chain of thought that happens in the background where the model produces lines of working for its response. And these lines of working basically build the model's reasoning abilities. The DeepSeek R1 Zero model was purely trained on the GRPO method. While this method alone gave the model strong reasoning capabilities, the model still struggled with things like mixed languages. So here, the DeepSeek team also implemented multi-stage training to produce the DeepSeek R1 model. Here, they took the DeepSeek version 3 base model, which then was the latest model, and they put it through 4 stages of training. Step 1 is cold start, where they applied SFT on this base model using a very small dataset. The point of this step is so that the model gets a head start in its reasoning so that it produces less random responses for the rest of the steps. It's a small dataset because the DeepSeek team only used thousands of labeled examples. For context, SFT normally requires millions and millions of labeled examples. In step 2, we applied the first round of GRPO training, and this training is to help build the model's base or general reasoning capabilities. Step 3 is called rejection sampling, which is a fancy term for SFT on domain-specific dataset. So let's say we're talking about specific math problems, coding problems, language problems, medical science problems, etc. This round of SFT required more data than that in the cold start step. So to source this data, the DeepSeek team apparently used synthetic data or AI-generated data. Again, by market standard, they used a pretty small dataset here, and the fact that they used AI to generate the data also made it very cheap and easy to access. Using the output of an AI model to train another model is called distillation. By the way, there is some drama about that. And finally, they applied one more round of GRPO to further refine things and to finally produce DeepSeek R1. And so in summary, DeepSeek apparently saved a lot of money by being very clever and efficient with the reinforcement learning process, which required less need for SFT and therefore less data needed compared to other model training methods. And that's how I understand DeepSeek's R1 training process. Stay tuned for part 2.